Hello and welcome. In this video, we will talk about the amount of an ordinary annuity. This lesson has been prepared for students who are taking the Grade 12 Foundations of College Mathematics MAP4C. Before I get started with the lesson, I want to go over some of the prerequisite skills that we need to know and learn before we start with the annuities. So, first of all, you have learned various types of investments so far, and you started with the simple interest. The simple interest formula is I equals PRT, where I represents the interest earned, so the amount of money earned from the investment. P represents the amount of money invested. R represents the annual interest rate, and I will emphasize the word annual interest rate. So when you go to the bank and you ask for interest rates, they're going to say, oh, we offer 2% interest rate. That means that that's the percentage of the principal that they will give you back in interest. So an annual interest rate. And last but not least, T, which represents the time. Now keep in mind that since the rate that we are using in this formula is annual, and annual is just another word for yearly, then the time must also be expressed in years. Okay? The second type of investment that you learned was the compound interest. In a compound interest formula, we have A equals P 1 plus I to the power of N, and A indicates the accumulated amount of money, and that's where the word A comes from, the word accumulated. And the accumulated amount of money is the principal you've invested and the interest earned together. P, as always, will represent the amount of money invested. I represents the interest rate. Now, unlike in simple interest formula, the interest rate in a compound interest is indicated by letter I. In a simple interest, R. R will always represent the annual interest rate, whereas I represents the interest rate per one compounding period. And I will explain this a little bit in a second. The letter N represents the total number of compounding periods. And you can look at N as giving an idea of how long the investment is going to last, or for how long you are investing money. So it's connected to T, or time. Now, one thing that we emphasized a lot is the fact that in a simple interest investment, the principal remains the same and the interest earned year after year remains the same as well. So they remain constant throughout the time of investment. So they remain constant. So what happens is that if you are investing $100 in a bank account and in a simple interest account, then the amount of money that you invest, the $100, will give you, let's say at 2%, $2 at the end of the year. So if you invest $100 at the end of the year at 2%, you can earn $2. The year after, you still earn interest, but the interest will always be based on the principal you first invested, so you're going to earn another $2. So you can either take the $2 out or withdraw it from your bank account or leave it in. You still earn interest only on the principal invested. Now, the compound interest, unlike in simple interest, whatever you earn is added back to your principal. So every time your interest is calculated, it will be calculated on a new principal, which is made of whatever you invested initially plus the interest that you have earned over the time. Now, very often when we talk about compound interest, we use the word compounding frequency. So the compounding frequency can be annually, semi-annually, quarterly, monthly, and these are just some examples because there is more to this. It can be daily, it can be weekly, it can be actually calculated by minute or a moment. So why do we need to know the compounding frequency? Now, the compounding frequency annually means that the money is compounded once a year. That means that the interest is calculated and added on to the principal once a year. In this case, we're going to say that the interest rate I would be equal to whatever the annual rate is divided by 1 because the annual rate is equal to the interest per one compounding period. There will be one compounding period a year. And the number of compounding periods will be equal to the number of years times 1. When money is compounded semi-annually, and semi means half, that means it's compounded every half of the year. So there are 2 halves in a year, so that means twice a year. There will be 2 compounding periods in 1 year. And what that means is that the annual rate, which is R, will be spread over 2 compounding periods evenly. So I equals R over 2. The number of compounding periods, on the other hand, will be the number of years times 2 compounding periods that are in a year. If money compounds quarterly, that means that every quarter of a year will make 1 period. And a year has 4 quarters, which means that money will compound 4 times a year. So the frequency of adding the interest to your principal is 4 times a year. So 4 times a year. Now, similar to the previous examples, we're going to have the interest per one compounding period equal to annual interest rate divided by 4 because the annual interest rate will be spread over the 4 compounding periods evenly. And the number of compounding periods would equal whatever number of years you're investing the money for times 4, which is the number of times per year. For monthly, the money will compound 12 times a year. It will compound every month. And since there are 12 months in a year, we're going to say 12 times a year. Similar to what we mentioned before, the interest rate per one compounding period will be the annual rate divided by 12, and the number of compounding periods will be the number of years times 12. And I really wanted to go over this because it will help us to best understand ordinary annuities. So just to start with, an annuity is a different type of investment, different than simple interest and different than compound interest. So what is special about annuity? In a compound interest investment, we invest a single principal, okay? And we let that principal grow over a number of compounding periods. So in an annuity, instead of investing a single principal amount, which is indicated by P in the compound interest investment, you invest a regular payments. Okay? So, and I will explain you how this works. And for payments, usually we use PMT for short. And in the graphing calculator and in many electronic devices, you will see this acronym for payment. Now, how does this work? When you invest in an annuity, you are making a commitment to invest equal amounts of money into your bank account over equal periods of time. So the accumulated amount will grow from 2 sources. Number 1, your regular payments, because you will always be adding on to your principal. So you make an investment of $100 every month. It means at the end of every month, you will invest $100. So in the second month, you will have $200 invested. Now remember that in the meantime, you've earned some interest on that $100 of the first month. So that would be added on to the accumulated amount. So there will be two sources from where the annuity will grow. The regular payments that you will make, and by the way, this is indicated by uppercase R, and the interest earned, so the money earned from the interest, right? Earned at the end of every compounding period. Now, the formula for the annuity is quite fancy, but nothing that you cannot memorize. We'll go over it together slowly. So here we go. So the formula for the annuity is, always start with A, where A is the accumulated amount, nothing new here, equals, it's just like in a compound interest investment. And you're going to draw a long line because we have a nice fraction here. And then we are going to also have 1 plus I to the power of n. And we all remember this from compound interest investment. Now, remember that before these brackets here in a compound interest investment, we had letter P that stood for the principal. Now we are not investing a principal, we are investing regular payments. So guess what's going to go in front of these brackets? The letter R. Okay? And now this is, that looks pretty much like compound interest investment, and this is when a few things will change. I'm going to add in here square brackets. Okay? And I am going to make two very small changes. Take away 1 and divide by I. Okay? So that's the only thing that makes the formula different. And I hope that this method of me laying out the formula can help you memorize it. Okay? Now let's get started with the lesson. So we're going to say that an annuity is a series of equal payments made at regular intervals. And all the investments are made at the end of each compounding period. Now, the amount of the annuity is the sum of all the regular deposits plus the interest. Or regular payments plus the interest earned. So what does that mean? So at the very end, you will earn, or you will have an accumulated amount of money that is made by all the regular payments that you've made n times at the end of every compounding period, plus the interest earned. Now, this is the formula for the amount of an ordinary annuity. We already went over this. We're going to give a meaning to each and every letter one more time. Letter A stands for accumulated amount. Letter R, regular payments. Letter I, interest per one compounding period. And last but not least, letter N is the total number of compounding periods. Okay? Now, to find the total amount deposited, we are going to multiply the regular payments by the number of times we've made the payments, and that would be the amount deposited. Sorry, I'm gonna give it a... And to find the interest earned, then we're going to subtract the amount invested, R times N, from the accumulated amount of money. Now, remember a few things though. Number one, this formula can be used, the ordinary annuity formula, right here, can be used under the following conditions. Number one, the payment interval is equal to the compounding period. Same. The compounding period. And the payment is made at the end of each compounded period. Now, if the payment is not matching, so the frequency of payment is different than the way the interest compounds, we cannot use this formula. So we have to use something else, okay? Now, the first payment is made at the end of the first compounding period. So we're going to take a look at a couple of examples and see how we use the formula. Suppose that Kalen deposits $1,000 at the end of each year for 5 years. His account earns 6% compounded annually. So how much has Kalen saved at the end of 5 years? So the first time you read the problem just to get an idea about what kind of question you're dealing with. The next thing that you want to look at is some keywords. So what kind of problem is this? So you are depositing money at the end of each year for 5 years. That's a regular payment. So you're going to say that, it looks like we have to use the formula A equals R 1 plus I to the power of n minus 1 divided by I. Once we have a formula in mind, then we reread the question with the intention of understanding where the information given in the formula, in the problem, would fit into the formula. So, he deposits $1,000 at the end of each year, and that is for 5 years. And the account earns 6%, and it's compounded annually. And we're happy that it's compounded annually, because it does say in here that the investment is made each year. So these two must match. Now we're going to write the information. I usually like to write the information on the right hand side of the space where I have to show my solution. So the $1,000 will represent the regular payments. The time of investment is 5 years. The rate or interest rate is 6%. That's annual. And what I want to find is how much Kalen has accumulated at the end of the investment. Now remember that the letters T and R, which are more commonly used or given in a word problem, are not the numbers that you can substitute directly into the formula, but you should use these numbers in order to figure out I and N. So what I like to do is right where I write the information, I also convert time in years into compounding periods. Since the money is compounded annually, I know that the number of compounding periods will be 5 years, once a year, which is 5. The interest rate, on the other hand, which I must remind you one more time, always write it in decimal form, not in percentage. And in our case, it's annually again. We're going to say that the annual interest rate will help us determine the interest rate per one compounding period. So 0.06, and we have one compounding period in a year. So that would be the interest rate. And from this point on, all we have to do is substitute all the numbers given. So amount A equals $1,000, and then times 1 plus 0.06 to the power of 5, take away 1, and divide it by the interest, which is 0.06. And now it's time for us to look at how we use the calculator to find A. Now, when you use the calculator to find A, remember to type in the expression just the way it is. So you have to write or type 1000, brackets, another brackets, 1 plus 0.06, power 5 minus 1, brackets again, and then divide by 0.06. The good thing here is that the denominator is just a number. It's not in fraction form. When in fraction form, the denominator must be kept in brackets when in fraction form, okay? So here we go. We have 1000, 1 plus 1000, and then times bracket, bracket, 1 plus 0.06 to the power of 5, and then minus 1. We close the brackets and then divide by 0.06 again. And that will give $5,637.09. So $5,637.09. That would be the accumulated amount of money. Now, if you're thinking, oh, okay, but how much money did Kaylin really invested there? So Kaylin invested $1,000 every year for 5 years. So the amount invested was $1,000 every year for 5 years. So he invested $5,000. How much money did Kaylin accumulated? Well, he accumulated 5,637. So at the end, he got more than what he invested. And where did this come from, this more? So the difference, it came from the interest earned. So we're going to say, so if you want to take the problem further, you're going to say the interest earned is 5,637.09, take away 5,000, and that will amount to $637.09. Okay, so there are some more examples that we can work on, and in the next example, which we're going to go over together, we are going to look at 2 ordinary annuities, and we want to see how they will be different or maybe same. Who knows? So, Alanis deposits $450 at the end of each quarter for 1.5 years in an investment account that earns 10% compounded quarterly. Okay? So always look for the key words here. So every quarter she's investing money and the money is compounded quarterly. So that means we can use the formula A equals R 1 plus I to the power of n minus 1 divided by I. Okay? And now we're going to say, what are the options here? Well, she's investing $450, okay? So the amount of money invested is regular payments of $450. She's investing every quarter for a time of 1.5 years. And she's going to earn 10%. That's a very high interest rate. It's very hard to find these interest rates nowadays. So, and it's compounded quarterly, so we will need to find out how much she earns at the end. So as we said before, we need to make sure that we use the number of years and the annual rate to figure out what the values of n and I would be in our formula. Since the money compounds quarterly, then the number of compounding periods would be number of years times 4. The interest earned would be the interest per year divided by 4. Remember that this must also be written, or always be written, as a decimal 0.1. And I'm going to make this green to be consistent. Quarterly. So here we go. We have everything we need. We're going to substitute into the formula to answer question A. So we have the amount equals regular payment $450. And then 1 plus 0.1 divided by 4 to the power of, remember 1.5 times 4, we can easily multiply that 6. So there will be 6 compounding periods in a year and a half, because 4 quarters in 1 year, 2.5, right? And then minus 1, and that will be divided by 0.1, divided by 4. That looks like a fancy 0 here. So now we are going to use the calculator to find the answer. So amount equals, remember that when denominator is in fraction form, you got to keep it in brackets when you type the numbers in the calculator. So here we go. I hope I remember all these numbers. So 450, and then times bracket, 1 plus. The interest rate was 10% compounded quarterly, so 0.1 divided by 4. And that was brought to the power of 6. And then take away 1, close the brackets, divide, open the brackets for the denominator, 0.1 divided by 4. And press enter. I got $2,874.48. If I remember it correctly. Okay, so 2,874 0.48, that is correct. Okay, perfect. So this is the amount of money that Alanis made. Okay. Now, how much money did Alanis invest? So, and how much interest did she earn? So that's what we are about to find, how much interest Alanis earned from this investment. Now remember that Alanis invested $450 at the end of each compounding period, and in total she had 6 compounding periods. So that means that her total investment, like the total principal, right, that she added, step by step, after every compounding period, would equal 450 times 6. So 6 times 4, 24, and that's $2,700. That's how much money she invested. Now, at the end of her investment, she made $2,874. So when you compare these two numbers, you see that they are different. So the accumulated amount is greater. And it's supposed to be because we know that this investment that she made earned some interest, okay? So the interest earned equals 2,874.48, take away 2,700. So the interest earned equals $174.48. And this is it, okay? So if you understood what an ordinary annuity is, don't waste more time, but start practicing the rest of the questions provided in this handout, okay? I hope that this made sense, and I hope that you learned something new today. Bye for now.